Welcome to this explainer. Okay, today we are looking at something that honestly feels like it belongs in a sci-fi movie, but it's actually happening right now. We are talking about a massive, and I mean absolutely massive, paradigm shift in computing. We're talking about the shift from static, dead files to living, breathing simulations. We're going to explore this fascinating, super detailed patent application titled Executable Companions from Digital Objects.
So let's just dive right in. I want you to imagine something for a second. What if you could click on a totally static PDF, like say a really dense scientific paper, and literally execute it? What if you could take a single photograph of a landscape and just turn it into a living, tweakable simulator? You know, we're so used to our documents just sitting there, right? Just trapping information on a screen. But what if we could actually breathe life into them, transforming them from something you simply read into something you can actually run?
And look, this isn't just some wild dot experiment. This right here is the actual United States Patent and Trademark Office submission receipt, pulled directly from our source material. It was filed on May 11, 2026, under application number 19/673624. So this futuristic tech, it's actively being codified into intellectual property as we speak.
To really ground how real and immediate this is, check out this official electronic payment receipt from the USPTO. The inventor, Uri Kartoun, actually paid the $400 filing fee to the Patent Office to examine this exact system. The future of how we interact with our digital files is quite literally right around the corner, and this official paperwork points right to it.
Section 1. The Static Data Trap.
Let's understand the core problem this patent is actually trying to solve. Our digital world is overflowing with rich documents, right? Scientific manuscripts, patents, historical records, financial reports, images, you name it. But they are almost entirely static. The underlying data in these objects is basically trapped. Sometimes it's locked behind privacy restrictions, like patient data in a clinical trial. Other times it's proprietary, or maybe it just doesn't exist anymore because it's from before we even had computers. We can read the summary statistics, sure, but we can't play with the actual mechanics. We are basically trapped in a static data paradigm. Now, you might be thinking, wait a minute, can't current generative AI just write me code or data based on a prompt? Well, yes and no. Current generative AI essentially gives you a one-shot output that, let's be honest, frequently hallucinates. It completely lacks schema consistency, which means it really struggles to keep data formats and rules aligned if you run it multiple times. It doesn't trace parameters well or respect strict constraints. But this patent? It introduces something vastly different, the Executable Companion. Unlike your standard AI outputs, this thing is constrained by construction. It is highly deterministic, and it operates in a securely sandboxed environment. This guarantees that the generated output perfectly obeys the strict rules, the physics, and the logic defined in that original source document. Which brings us to Section 2, the Executable Companion. Let's clearly define exactly what this system creates to solve that whole frustrating static data trap. An executable companion is defined as a generated computational artifact supporting parameterized regeneration derived entirely from source objects. Okay, so what does that actually mean in plain English? Basically, it means the system creates a reproducible simulator. You can poke it, prod it, tweak the parameters, and run totally different scenarios, all without ever needing access to the original underlying data. It builds this simulation based purely on the contextual clues, the constraints, summary stats, and tables trapped inside that static file. And it uses advanced statistical tools like Gaussian copulas to automatically preserve the complex mathematical relationships between all those variables.
Section 3. Under the hood.
So how does this actually work? Let's take a look at the step-by-step pipeline described in the patent that literally builds a living simulation out of a dead document. First up is structural extraction. This is where a multimodal large language model parses the document or image, pulling out variables, equations, constraints, and relationships. Second, it builds an intermediate representation. Think of this kind of like a structured blueprint or a schema that holds all those rules together. Third, we get code generation. Here, the system actually writes executable code using languages like Python, R, or Julia, and it encodes those extracted constraints directly into the programming logic. Fourth is sandboxed execution, where that generated code is run in a super safe environment. And finally, number 5, package assembly. This is where the code, the generated synthetic datasets, interactive figures, and the documentation are all neatly bundled together into one handy companion package. Now, let's zoom in on step 4 from that pipeline for a second. The sandbox. Because the system is writing and running code totally autonomously to generate your data, it absolutely has to be fiercely secure. This isolated execution environment enforces some incredibly strict limits. It completely blocks network access, it heavily restricts file system interactions, it caps execution time and memory consumption, and it totally prevents any unauthorized package installations. This specific technical setup is absolutely vital. It ensures that generated code can't just run away with your system resources or make sneaky, unauthorized changes to your computer. It's all about safe, deterministic exploration.
Moving on to Section 4, bringing data to life. The theory here is super fascinating, but let's look at some extreme real-world applications to see how this actually works in practice. Look at this number, 150,000. According to the source material, the system processed a single, statically published clinical paper. Now, without having any access to the original, highly private patient data, the system extracted the summary stats, demographics, laboratory variables, and physiological ranges. From there, it generated an executable simulator that, when run, produced a synthetic dataset of 150,000 hospital admissions across 100,000 simulated patients. That is wild, and all of this perfectly preserved the statistical properties, the means, and the medical correlations of the real study, but completely bypassed the privacy bottleneck.
And honestly, it gets even more interesting. If you feed the system a planetary surface image, like a photograph captured by a Mars rover, it generates a 23-parameter erosion and lighting simulator, where you can dynamically change the wind and solar angles. Feed it a static screenshot of a financial stock chart, and it spits out a Monte Carlo simulator for intraday price paths. It essentially generates thousands of possible future scenarios for that stock to gauge probability, complete with confidence bands. Give it a super dense, text-heavy patent claim, and it creates a parameterized design space simulator for modular energy storage, literally translating independent claims into invariant constraints and dependent claims into conditional logic. Or input a marathon route map, and it builds a simulator modeling a runner's physiology and the course dynamics based on elevation and weather. It basically takes flat, dead inputs across virtually any domain and builds these multidimensional interactive sandboxes. It's like magic, but it's just really good math.
Section 5. The next digital frontier.
Let's wrap up by looking at how this builds a massive paradigm shift for how we interact with our digital files every single day. The patent envisions this incredible future user experience, highlighting what could honestly become a ubiquitous feature across the entire internet. Imagine you're browsing a journal article, a patent database, or some digital archive, and you see a simple Run Companion button right next to the text or image. Instead of just passively reading a study, you click that button. The system initiates on-demand generation right behind the scenes. It processes the paper, writes the code, executes it in the sandbox, and instantly hands you a synthetic dataset with interactive figures. You can literally stress test the author's claims right there in your browser, just changing parameters to see how the results shift. Talk about a real game changer.
So I want to leave you with this final, provocative question. What happens when the difference between reading a document and running a simulation completely disappears? We are standing right on the edge of a world where every PDF, every chart, every map, and every single photograph on your computer isn't just some static record of the past, it's an interactive engine for exploring the future. The data trap is finally opening. Thank you so much for joining me on this explainer of the Executable Companions patent. Keep exploring, and I'll see you next time.